Howdy, hey, hi, Spaceman Josh here. And so today I wanted to take a little bit and talk about interstellar travel. And so I know that last week I talked about robots versus humans who should explore space. And I think it's important to talk about a little bit as well as sort of how we want to go about in terms of the spaceships and fuel and all that kind of stuff. In terms of how we actually do want to go and explore space. And I'm not going to touch a lot on what we do now or what we did in the past. A lot of that stuff is easily lookupable, and it's something that really it's if you want to know about it, I encourage everyone to go and look up in the free time. But it's not what I'm going to focus on in this video. I want to focus on some of the ways that we can look at sort of looking towards the future for space exploration and interstellar travel, or even in a sense maybe even intergalactic travel, when it centuries in the future with technology. But ultimately, so for interstellar travel, when talking about sort of the fuel sources and things of that nature, what's really nice about that sort of when we think about the amount of fuel we need and the amount of thrust we need to produce for a spaceship that's on the Earth, the weight to thrust ratio you need, so essentially the amount of thrust that you can put out compared to and the ratio it has with the amount of weight that your spaceship weighs, it depending on what you have, it actually needs to be a decent number. But with things out in space, and for most cases, you can actually have that ratio be less than one, in a sense that you don't need a lot of thrust to move your objects out in space. And so a lot of the machines we currently use are one of them is called a Hall thruster, but there's another one also called a Q thruster, where essentially right now in modern times it's actually fairly weak compared to some of the other thrusters we have, so it's not practical for for current use. However, with a lot of stuff that we've been looking into for various things, things involving the quantum vacuum and negative pressure, things that go even way over my head that I'm still trying to understand myself. Things of that nature, Q thrusters actually do have the potential to are getting a lot better, and there's some research going into that makes them a lot better and for having a certain newtons per kilowatt power output. I think I said that right. This is a very for me this is also still a very new field, so bear with me if there's some information that I get wrong. If I do, go ahead and correct me in the comments below. I'll put that out there now. I'm not 100% on what I'm talking about, but I did do my research, and so there's some things that I may get right, I may get wrong. So, sort of moving on, the first thing I sort of want to talk about is that the idea that if we're talking about future, what we really want to look at is being able to travel faster than light. Now, as said in some of my space-time videos, nothing travels faster than light. And that is true 99.9% of the time. With the expansion of the universe, there's this sort of idea called inflation, similar to other ideas where what the word inflation means. And now if we look at a star out in out some distance out in the universe, the light that we're going to see from that star is going to be redshifted because the space between us and that star has shifted since the light had left that star. It's what's known as redshifted. There's something called a Doppler effect that has all that. I may go that into a later video, but for now, there's this thing called a Doppler effect that makes it redshifted. The light changes compared to when it left, and it's because the universe is expanding. And the interesting thing about space and its expansion and in its inflation is it can go at whatever speed it wants. It's not constrained to the same boundaries as normal things, like how even with light you can only travel at the speed of light, and anything with matter can only travel at the speed of light. But what's interesting is this concept is that space itself can expand and contract faster than light if it wanted to. And so there's a couple of loopholes to sort of make this happen. One of them is sort of wormholes. And so I don't know a lot about wormholes. It's some of the stuff is very some of the stuff is very iffy. Wormholes is still a very new concept relative to the science world. The sort of the general idea for a wormhole would essentially be you go in one side in one part of space and you end up another. And currently, an idea to sort of think about a sort of a wormhole is if you think about the sort of the gravitational influence of a black hole. I have the image up here. Essentially, where up here would be where the black hole and sort of the gravity sort of caves in as you go in, but at the same time, and then it eventually sort of concaves out, essentially sort of like a reverse effect. And essentially, the idea where if you went to this black hole like structure, you'd come come out somewhere else, and sort of this idea that it would be somewhere else in space. And that's generally the idea of wormholes and how that idea works with everything everything I've been able to dig up and whatnot. However, there is another topic, another loophole. There's about two loopholes I've been able to find. One of them's wormhole. Another one's a lot more interesting to talk about for me at least, and as well as there's a lot more that I've been able to look up with it, and it is the warp drive. And I am talking about a similar warp drive to the idea with Star Trek and that whole shebang. So this idea of the first idea for a warp drive actually came up by this theoretical physicist named I'm sorry if I butchered this name, Miguel. What was his last name? I have it here. Just one second. Okay, yeah. So it was Miguel Alcubierre. I can't pronounce it correctly. I'm sorry, but that's generally his name. He's a theoretical physicist, and he came up with this idea of sort of what I have up here in the upper left of the screen is sort of this idea of taking space-time and sort of having this. If you were able to contract it forward, that would be over here where it's the plane is going downwards, and if you were able to contract space in front of the ship, and then as well as then expand it sort of over here, sort of expand it behind the ship, so inside the flat area inside where those two hills are, that would be the ship is in there, and if you were able to contract the space in front of it and expand the space behind it, you could essentially have what's known as a warp bubble. And it's the idea that essentially you move space-time around the bubble. And so one of the big drawbacks, there were a couple of huge drawbacks. One of them was that the amount of energy required to create that warp bubble, with the idea that Miguel Alcubierre put out, was that it's beyond anything we can actually do. And on top of that, one of the things that I even learned in school when this topic came up was that the temperature inside the warp bubble would actually get so extreme that no life inside of it could survive. So essentially, you could have this theoretically, if you got enough energy to create the warp bubble, you still inside the warp bubble, it would get so hot that nothing could survive inside of it. So it wouldn't matter anyway. However, there's a bunch of other scientists currently now. One of them, his name is Harold White. There are a lot of scientists that are looking at this idea of a warp drive and trying to see it, trying to take it from an impossible thing to a plausible thing. We still can't do it, but can we make it plausible? And that's what this image here is sort of one of the things that Dr. Harold White did was sort of this idea of having the warp bubble having the expansion contractions things be really, really thin. And sort of the idea for making the warp bubble was you'd have to have rings, sort of having sort of rings and having the ship inside the ring, and so this sort of idea of you get over here you'd have really thin rings, and you'd have to create a lot of energy. Sort of the higher up those hills are, the more energy it takes to be able to make the warp bubble, and sort of really, really, really thin rings, almost sort of like compared like a wedding band on this end. If you at the same time if you sort of make it so that way the rings that you use for the spaceship are thicker and thicker. I hope I'm saying this in the right way. But if you make them thicker and thicker, comparing it like taking them to like the thickness of a wedding band to the thickness of a lifesaver, You know, essentially the area inside it, sort of on this end, the area inside of the warp bubble is a little bit smaller, I think, from my understanding of it. But at the same time, the amount of energy required to make that to make the warp bubble is a lot less. Taking it from impossible over here to plausible. It's no longer completely out of our reach to be able to sort of make a warp bubble with this that requires this amount of energy. The thing is, we still don't have the technology to sort of with full assurance say that we can make a warp bubble. There are a lot of different there's a lot of different scientists, including Harold White, going through and trying to do different tests involving warp bubbles and trying to do very small scale things at first and trying to see what we can do and learn more about the field itself and learn about warp bubbles and that sort of thing. So that way we can sort of develop the technology and make it more advanced. That way we essentially can end up, so we could actually end up with, you know, a warp drive. It's not that far-fetched of a concept. And with it, we're able to travel faster than light because inside the bubble, we're not moving. The proper acceleration of the spaceship inside the warp bubble is zero. The thing that we're doing is we're taking the warp bubble and we're moving space-time around it. In space, like I said earlier, space can contract or expand as much as it wants. And so it can do it at any rate at once. It can do faster than light. So that's essentially the idea of if we can make it to technology where we can actually do this. And there are some conceptual spaceships that, you know, sort of NASA and some overall people have sort of thought of. And you can look some of them up. They actually look really, really cool. But it's essentially this idea that we can have a warp drive that allows us that way, by moving space-time around us instead of us moving through it, we can travel faster than light, and which is exactly what happens in Star Trek. With Star Trek, if the numbers vary a bit depending on, you know, where you get your numbers and what the math does, but from the things I've looked on online, so Star Trek's The Next Generation, their warp 10 would be around the equivalent of would be essentially, you know, velocity of essentially infinity. There is no limit to it, but getting right before it, like warp 9.9 or warp 9.99, that sort of range, you'd be going it's an exponential function, but essentially around that area you'd have speeds of around, if I remember correctly and read it correctly, that there is a lot of making sure you can read the article correctly, but essentially it's around 6,400 times the speed of light would be, you know, sort of their, you know, warp 9.9. For, you know, Star Trek, the USS Enterprise, and Star Trek: The Next Generation, 6,400 times the speed of light. That's like speed that we can't even conceptualize at this time, because we're still bound by this idea that before we can actually effectively create this technology that allows us to do this, we will effectively never be able to get past the speed of light, or for other purposes, other laws of physics, ever be able to get past, you know, 30% the speed of light, even that. But with warp drive, we're not moving. Space-time is. So that's what I'll leave you with. So thank you for watching. I know this is very, very jumbled and sort of very rant-like. And so I do encourage everyone to go and sort of look up this information a little bit more. But other than that, thank you for watching. If you like to go and hit the like button. If you want to see more of my videos, I promise most of them are a lot better than this. Go ahead and subscribe. If you want, you can also hit the bell and turn on notifications. Other than that, thank you for traveling with me today. Spaceman Josh, out.